Now that you have a better understanding of the changes offered by USB 3, I'd like to now talk about the pros and cons of USB. By now, it should be fairly obvious to you what the pros are of USB. Here's the main pros of the specification. Obviously, the faster data rates at 5 gigabits per second, the backwards compatibility to both USB 2 and USB 1 at the signaling, cabling, power, and software level, the new power saving mechanisms, which in some cases can save up to 1/2 to 1/3 the power of typical USB devices, and a directed packet protocol. With all these great things that USB brings, there are still some drawbacks to the technology that will slow down its adoptance in the marketplace. The biggest challenge right now is that with higher speed signaling that is demanded of USB 3, the copper used in these cables will limit them to around 3 meters when running at super speeds. For USB device manufacturers, one of the biggest issues right now is that there's no all-in-one device controller available on the market that contains both the PHY and link. USB 3 devices need to use a separate PHY and link controller, which can increase the incompatibility between other USB 3 devices as each manufacturer tries to interpret how the specifications should be implemented. I expect that shortly, in the future, more and more USB chip manufacturers will address this issue and come up with a one-chip solution for USB 3. For now, USB devices will tend to be more expensive as chips are needed and IP is required to design and develop new USB 3 products. As this technology is still in its infancy stage in the consumer marketplace, there are still some challenges with the adoption into mainstream computing. The biggest challenge is that there are no native host controllers and class drivers available for Windows. All the drivers currently are being provided by the manufacturer, which typically may suffer from interoperability issues, and more of these drivers are created. Also, only higher-end PCs and laptops come standard with USB 3. All other PC and laptops require the need for an additional adapter card. Finally, with the speeds and volumes of data being processed by USB 3, many of the current computers in the markets will be challenged to keep up. High-end PCs will be required so that they could be able to keep up with the service requests and data coming from USB 3, while still providing processing time for higher-end applications to handle and process all the data in real time. Now that you have an understanding of the challenges of the USB 3, I'm going to give you a quick overview of where it is in the consumer marketplace. More and more, USB 3 is gaining traction in the consumer marketplace. The quickest adopters of the specification have been the external hard drive and flash drive manufacturers. By far, they have embraced this technology and continue to introduce new products on a weekly basis. Also, if you're starting to see more and more PCs and laptops running USB 3 ports with built-in when you get them from the computer shop. Also, as for the support for bigger players, you're also seeing more and more signs that are coming on board. Linux currently provides support for it in its kernel versions greater than 2.6.32, and Intel is stating that it will provide support for USB 3 on its Cougar and Huron River platforms in the coming months. Microsoft is also announcing that Windows 7 will provide native support in an upcoming service pack and state that Windows 8 will have full support of USB 3 when it's officially released. What does this mean for the machine vision market? In this section, I will talk about how USB 3 will change how you implement your next imaging solution. For machine vision, the benefits of having a faster bus are numerous. With higher bandwidth, there is no need to compress or reduce the ROI to get the faster frame rates. Much of the color processing that was currently being done on the host PC can now be offloaded to the camera, where fully rendered RGB data can be transferred faster across the USB bus, thereby freeing up the host PC to do other processing in real time. Also, more cameras can be connected to one PC and stream data at full resolution and at full frame rates on one USB bus, where, in the past, multiple adapter cards were required to ensure the highest delivery rate from all cameras. Another option that's provided with larger buses is that more and more cameras can be created with larger sensors running at faster and higher frame rates. This will eliminate the need for multiple cameras in one system, combined with all the synchronization issues that went along with them. With higher image transfer speeds that will be available with USB 3, latency between image capture and image delivery to applications will be greatly reduced. Communication times between applications and cameras will be dramatically quicker, allowing for more real-time control of events and camera settings. With the introduction of full duplexing and bursting, more tasks can be done in parallel, allowing for faster responses to camera setting changes and quicker image delivery. With the additional speed provided by this technology, more and more sensors that were once deemed too fast or too large can now be built into less expensive cameras without the need to purchase expensive frame grabbers or do any complex compression, binning, or subsampling of the image to maintain desired frame rates. More power over the USB bus allows features to be added to the camera such as bigger processors, DSPs, and FPGAs to support more onboard processing of the images without the need for additional power source. This helps reduce the number of cables required for the camera, thus making the camera easier to integrate into existing imaging applications like line monitoring. More power to the camera also means that more power can be provided to the GPIOs. This will allow the camera to provide direct control on peripherals without the need for an additional powered I/O boards. Finally, with the green initiatives that have been implemented in USB 3 specification, cameras built around these features will be more efficient in their power usage. Now that at this time, with all this information, I'd like to make you may need to make a decision on whether or not it is right for you. In this section, I will present some additional information that will help you make a better decision on when is the best time for you to migrate over to USB 3. The main question you're probably asking yourself is USB right for you? It can be if you're willing to take on the challenges of a new technology that is early in its life cycle. As with any new technology, it can sometimes be a challenge to iron out the kinks and make the stable platform. Early on, costs to maintain and support new technology will be really higher. However, these challenges may be minor given the benefits provided by this technology. Other aspects of your application may be well suited for USB 3. If you have a need to work with multiple cameras, higher resolutions, and/or higher frame rates, USB 3 may be the right solution for you. If you have an application that is demanding on the host PC and are looking for ways to offload some of that processing to the camera, or you may be looking for a more efficient camera for both the image processing and power management perspective, USB 3 is right for you. If all these points are right, then it makes sense for you to move to USB 3 sooner than later. When is the best time to invest in USB 3? This is a tough question to ask and only you can answer it. Here are some of the points you need to consider before investing too heavily in this technology. As it is still early on in the USB 3 lifecycle, you need to consider the investments and support you'll need to put into the product, given that most OSs and camera drivers are not fully stabilized yet, and almost all PCs running in the world do not have support for USB 3. From a camera manufacturer's perspective, there's still not a simple and cheap solution on the market for USB 3. Camera manufacturers will need to create and maintain their own USB 3 solution and deal with the interoperability issues that may come up as more and more USB 3 devices are created and integrated. Finally, the big consumer companies like Microsoft, Apple, and Intel are not fully on board yet with products that are natively support USB 3. So where does this leave you? What do you need to know what you need to do now if you've identified a potential need for USB 3? The first step is you need to look at what your future needs are and see how USB 3 can service them. You will need to work with your camera provider to ensure that these needs are going to be met in their new products. Also, you will need to plan the development of your products around the introduction of these cameras to keep your suppliers, introduction of the cameras from your suppliers, ensure that the cost of these products and their support are kept within your budget. Thank you very much. This concludes my presentation. I would like to thank you for taking the time to watch. If you have any questions, I'll be free to answer them just on the side here after the presentation, or you can come see me at my booth. Thank you very much.